Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about multimeters, and it's a big topic, so I will break it into parts. So first we have to understand what it is. Well, we rely on electricity flat out every day, day in and day out. We rely on electricity. So electricity is not an optional choice for us anymore. It's a necessity. And I don't mean electricity that you get from the grid. That itself is a very big part, undeniably so. But on top of that, there are many scenarios where you have to know, let's say, the voltage of your car battery. Because again, let's say you have not started it for very long while and you have a very low ampere charger for it. You don't want to drain this puppy trying to fall started, cold started. You will be like, hey, if I can measure the voltage, it's like if it's below, let's say 11 volt, I'm gonna charge it for then I'm gonna try to cold start my engine. That way you can save the battery from extra strain. And not to mention, if you drain it and it's like if the battery tried to do that, it will be discharged very quickly. Then you have to charge for 8-9 hours. So you can understand that like batteries, DC volt batteries are very important even for your computer and safety. Basically, if you have a computer that is like not very advanced, does not have multi-layer encryption and security system, people can just remove the battery and then with like tada, you bypassed your circuit system, basically a password system. And in some other scenario, other things could have also happened. So again, you also measure it. Like let's say your computer starts to beeping and the beep code is like check RTC, but how do you know whether RTC went like the battery is dead or the circuit is dead? So only way to check that is to check the cell. Only way to do that is to for our voltage system and clocks and all that. Every knick-knack we have in our life generally requires one form or the another form of batteries. So it's a very critical thing. So measuring and monitoring allows us to be aware of things, what we are doing, how we are doing it, and all that matters because safe operation of anything requires you to know the damn thing. What do I mean by that? Think of this way. Let's say this television is designed for 5 ampere. The plug I put it in is 6 ampere. Everything is fine and dandy. But let's say if I live in India, we do have very bad electrical quality. So sometimes voltage can go, we're supposed to get 220 volt, but sometimes it goes really low. And I mean 150 volts or sometimes even low as like a 70 volt. Now, what happens then? Again, in more normal scenario, this will shut down. But what if I'm getting frustrated by that and I put a stabilizer there and stabilizer boosts up the voltage? Everything is fine and dandy. My TV is working, but here's my plug is now on fire. Why? Because I draw too much current from it. That is the critical aspect. You have to know these things for your own safety. Not knowing that, not like just relying on someone else to fix it is very again, it's like why you are doing this. It's like it's no longer in a world where we're like, voltmeters, multimeters and all that used to cost like an arm and a leg in back in the days. Now it's dirt cheap. So not having these sort of tools, not having the knowledge that you rely on these, it's not an option where it's like who cares. No, you have to know what voltage is, you have to know what ampere is, because your whole world revolves around it. So for this reason, we have to have a tool to measure it. I've made so many videos about power plants, so many videos about batteries and all that, but you have to know a way to measure it. So first thing we measure always, generally, most of the time, is voltage. Why voltage? Well, it's the first thing you can check very easily, and voltage is what we call technically potential difference, basically difference between your positive and negative, and then it causes electrons to flow. Now, every battery you take, no matter which kind, no matter which geometry, no matter which chemistry it has, it always relies on voltage, and voltage can tell you a lot. Flat out it can tell you a lot. For example, let's say you have a basically wall clock and you are going through batteries way too quickly. So like, bro, I replaced it like 2-3 months ago and I'm replacing it again, again. If you can have a multimeter, basically even a cheap one, and I mean super cheap one, with this literally is a $1 or $2 item, you can check the voltage and you're like, hey, the voltage is very high, it's like around 1.3 volt, so the battery should be working, but it's not. That means your clock is now either poorly lubricated or has some fault. You have to replace the clock, not keep replacing the battery. How would you know that? You have to use a multimeter, and that's the reason why like this sort of battery clamp meters are available in Amazon and all that jazz. Again, what it is just a voltage meter. So if you can find correct voltage of every battery, be it 9 volt, be it 1.5 volt, be it some lithium ion which is generally used for flashlight, and you are saying the battery is within the tolerable range for the voltage, but for some reason your equipment is not working, that means equipment is faulty. So for this reason, you will easily see, like any commercial building or any practical building, you will generally, if they have a lot of power draw, they will have meters like this where you can easily see per phase voltage. Basically, again, in India we have either 3 phase or single phase, we do not have double phase. So it's like 220 volt, 220 volt and 220 volt, and then it was like 480 volts phase to phase voltage. So these sort of important information makes us safe. It's like, bro, we know what's happening. And if for some reason, let's say this happens if you have three-phase power and it's unbalanced for some reason, let's say the electrical grid was not stabilized properly, you could have in a scenario where it's like, let's say one phase shorts and the power of that is dumped into these two other things. It could happen anywhere. It does happen. It's surprisingly common everywhere. I do not mean just in India. It's surprisingly common all over the world that in some scenarios you could have a scenario where energy from those phase basically went into to another one. So your normal phase voltage will go ludicrously high. And here's the deal: surprisingly large amount of circuits, they will still keep working at very high voltage, specifically lead based products, basically light emitting diodes you have in your lighting system and all that. You can check the voltage range, they're huge. Like in India, we can easily buy that starts working from 90 volts, keeps working at 300 volts. Basically, I don't even have to think about anything. I can just plug it in, like USA, it will still work. I can plug it in India, it will still work. And heck, it's even frequency independent. So inherently, there are many products that will keep working. But if your voltage is 300 volts and you keep running it for long, poof, and it has happened to me. So for this reason we check voltage, and that's why if you buy a stabilizer, a UPS or anything like online UPS, you will always see giant digital displays. And even it, like you are buying let's say APSC, UPS and all that, they will have generally big ones, high quality ones, they generally have a USB interface where you can check the voltage. And if you keep saying, hey, voltage is going way too up, way too regularly, it's like, bro, something is bad, get something fixed. So for this reason, from battery checking to like knowing the quality of service that you are getting from your electrical system, or maybe some scenario you have, let's say solar power plant in your rooftop, it's going through inverter and giving you AC power, the voltage is too fluctuating too much. How would you know unless you know the voltage? For this reason, for quality, we have to know the voltage, and voltage tells us a lot. And that's why this is the first thing generally we teach in school. It's around class 7, standard 7, we generally study these sort of things in CBSE curriculum. 7, 8, we have to study these things. So like, and we start with very small, again, voltage, normal things, and then I'm reasonably sure all of you know about these kind of batteries generally used inside UPS. Again, 12 volts, so you can touch it, you won't have it. Don't touch with your tongue, it will taste really bad. Don't ask how I know. So you have to understand, knowing this kind of information is crucial for your day-to-day life. Like, how would you know whether you have to buy a new UPS or replace the battery if you do not know the voltage? Again, if the voltage drops below 10, yeah, it's time to replace the battery. So voltage can tell us a lot. We have to know this. Then we come to the current aspect. Now current is what gets the job done. So current is the main power drain. Now here's the deal, and this puppy has a very bad habit of setting your house on fire. Now you're like, wait a minute, how the heck it can do that? Voltage, while it has its own unique challenges, which includes it being emotional. What does that mean? That simply means if you have two conductors, naked conductors, atmosphere between them can become conductive. It's very high voltage. So generally we try to keep the voltage as low as possible. Now it's the relationship is not very linear. So it's like if 100 volt, 200 volt, it does not make too much difference. 500 volt, now you are in serious territory. Basically it can jump upwards of 1 inch, and if it's raining or something like moisture is there, there is a very serious risk, it will arc. Now that causes a very serious fire hazard, because that's a freaking plasma. It will set almost anything on fire. That's the reason why we step down the voltage for home delivery. And power plants generally produce very high voltage, so the ampere is less, and they can transmit it. And you will always notice how the heck you know the voltage. See how far apart the conductor is. If you see a pole which has conductor this far apart, generally they are 11 kV. If you see something that is like YOLO far apart, that's around 33 kV. If it's ludicrously far apart from one conductor to another, that's like even 220 kV. So that's the easiest way to. So now for voltage, for normal day-to-day life, unless multiple failure points happen, let's say lightning effect happen, even for that generally they have lightning arresters to make sure that does not happen. Let's say something like bad happens, then only voltage was called fire damage. But ampere, it generally sets people's home on fire way too regularly. Why? Simply because ampere is directly cause of heat. Why? Because your conductors are not superconductors, they have resistance, they heat up. So for this reason, every socket in your home, every plug, every power strip, every power squid, anything you buy generally will have a giant ratings yelling at its back. It's like, bro, do not drain more than 6 amps. Do not rated for 10 amps, rated for 15 amps. What happens when you drain more than that? Again, it heats up, it exceeds its thermal capacity, and then it can catch on fire. Now in olden days, our insulators were so bad it would literally set itself on fire. And this is the time when circuit breakers were introduced. It's like, bro, overcurrent, shut the damn electricity down rather than setting houses on fire. So you can understand it's that serious. And many times these circuit breakers fails, specifically if you are doing it slowly enough. It's like they are very good at that. The surge spikes, they're like, I got this, bro. I am like, you're totally safe from that. But if you're slow drain, it can cause much more damage. And worst of all, it piles up damage. Basically, your conductor will have an insulator. That insulator won't be damaged in 1 hour overdraw. It will like little bit singe. You put bit more, little bit more, little more. Like day by day, you can pile up a damage and tada, your house is on fire. So you have to understand that ampere is something that you have to take very seriously. Thankfully, you can measure it without getting electrocuted because you do not have to touch a conductor using these puppies. These are super cheap. You can get this for $2 or less. Do not buy online because, like, again, if you're buying online, try to buy something higher quality. But these are something like you buy from a thrift store or dollar store, something like that. These are very cheap, effective, and you just put your conductor through this and you can just measure the ampere and all that. So it's very safe in that regard because you are not directly touching the conductor. So if you have a, let's say, stabilizer, you can check the conductor and you'll be like, okay, the stabilizers have like, live, ground, and earthing. So live will be giving you the ampere, and you can check that, hey, the socket was designed for 10 ampere or 20 ampere, but if you are drawing too much or too close to it, basically it's 10 amp and you are drawing almost 10 amp, it would be a very wise idea to invest into 15 amp circuit to make sure that you do not, like, it's never a good idea to push it to almost that limit. So for this reason, power draw monitoring in ampere is a very critical aspect. Another uses are generally for people who deal with car mechanics. You will always see, not always, but you will many times see they have clamp meters. Now most cheap clamp meters can only work in AC. Expensive ones can work in AC plus DC. DC one requires a different kind of architecture, so it's a bit more expensive, but it does work. And modern ones specifically comes with data hold facility. So because if you have a car, let's say you want to figure out, hey, how much power my basically starter motor drains, because again you have to replace the battery, you want to know like how much is draining, so you do not either overspend or underspend. In those sort of scenario, you will be like, okay, I'm going to put the clamp meter and I'm going to start the motor. Now generally these sort of meter will store the highest point it reaches, so it will be like, okay, 100 amps, 400 amps. So then you will buy battery accordingly. You will not overspend, because let's say your car is so light, let's 3-cylinder engine is like barely gonna drain, let's say 150. You're gonna buy a battery that is 200. Like, you're not gonna waste money on 400 because again it's not useful for you. For these reasons, clamp meters are very effective. They are very safe, relatively speaking, and again it has the ability to protect you from slowly burning your house down. For this reason, monitoring current is also critical for our day-to-day life. Then we come to the safest of them all, resistance. Now resistance is core of electronics. You take anything apart, be it motherboard, be it laptop, be it your mobile phone, no matter which, even this dumb watch, no matter what you take apart, generally there will be a whole maze of resistors. Now resistors have a huge range. Now what does that mean? That simply means when I'm talking about voltage, let's say live mains voltage that comes to your home, there is a very good chance it's below 500 volt. Unless it's a three-phase system, it's still below 600 volts, and again it won't even reach 600. It will be generally rated for 440 volts. So all things considered, you are always below 1000 volts. Okay, that's a range. So basically you must build a meter that can measure from 0 to 1000. That makes sense. But what happens when you are talking about resistance? It has multiple zeros. So you will start with as little as, okay, 30 ohms, 300 ohms, 3000 ohms, 3 kilo ohms, 3 mega ohms, 3 giga ohms. Like basically it goes to ludicrous level. And in one circuit board you can find, again, mega and gigas are rarely used, but you can easily find ludicrous resistance difference from every component. So even a cheap equipment like this, they will have like, okay, 200 ohms, 2000 ohms, 20 kilo ohms, 200 kilo ohms, 2000 kilo ohms. And this is a cheap one. Expensive one goes even higher than that, because the range in terms of resistors, they're ludicrous. Like the range, and especially if you're working with Arduino and Raspberry Pi and all that, you may like to have the resolution for low stuff. And if you're, let's say, for testing electrical heaters specifically, you can just connect the both sides. Make sure it's disconnected. Do not be stupid. You check that and you can easily see, hey, how much resistance supposed to be. And generally if it's a component that has serviceability in mind, they will specify the open resistance should be this much and that much, all that jazz. So generally for this reason, because of the range, ludicrous range, people will say, hey, if you have to deal with resistance, try to get something that has auto ranging. Because again, it may sound like fun and doing like this, but yeah, if you have to do that on a, well, we are trying to repair a TV or basically a laptop, you don't want to do that. You are not being productive. Basically, you are wasting time. So people generally buy something like this. They will have very few steps. Why? It will be like just select voltage, select millivoltage, or select ohms, select hertz and all that, because it's auto ranging. It will automatically figure out, should I measure in kilo ohms or should I measure in mega ohms or hundreds of ohms. It will auto figure it out ranging wise, in terms of like it's like your scale automatically, hey, you are measuring something small, I'm going to show you in meters. You are measuring something very small, I'm going to show you in millimeters. You are measuring something very big, I'm going to show you in kilometers. So that is why auto ranging is a must for basically resistors. Now resistors are one component of the three trinity of electronics. Basically you have inductors, you have capacitor, you have resistors. Everything in this universe is made out of that, at least in this human universe. So this is the resistance aspect. Now I'm talking about electricity, and it's no laughing matter. Basically, all I would ask you to not be stupid. Like I urge people to teach their kids electronics, simply because again it's in their school curriculum. I can guarantee that. And if you want to make sure your kid is like actually not dumb, basically many people say like, you know, this battery, this is in their UPS, it will run their computer for 1 hour. How the heck you can be that stupid? Because you never studied the damn thing. If you studied it, you will understand, hey, it's 12 volt, hey, it's 7.2 amps. That means you multiply that gives you 70 watt hour capacity. Only few laptops consumes less than that. So a laptop can run 1 hour on these puppy, but not your desktop. So how would you know that if you don't know the voltage, if you don't know the ampere, and if you are inherently unfamiliar with that? It's just like, hey, it's something that I buy. Okay, electricity directly controls your life. You have to know these things. It affects your car, it affects your inverters. Basically inverters are not very common in Western countries, but they are quite common in basically servers, data banks and all that. They have to require like huge UPSs and all that. How would you know how long that will run if you don't know the mathematics? How would you know why do I need this plug or I do not need this plug? How do you know whether you are like pushing your electronics to upper limit if you can't utilize a Clampmeter? Now you can always rely on an electrician, and you should do that if you have a fault. But again, you really want to wait for until like something catches on fire, then you're like, hey, I think something is bad is happening. Or you're tripping, like, you know, you're tripping your circuit breaker every day, then you're like, okay, something must be wrong. Do not reach a point where it's like you have to rely on someone else for something that basic. Do not take unnecessary, do not try to fix electronics unless you don't know what you're doing, specifically with mains voltage. Raspberry Pi, laptop, motherboard and all that, they're very unlikely to hurt you unless you are dealing with a really bad power supply. So you have to be very smart with this. You cannot be idiot around it. And if you have any doubt, like, should I do this or not, always do not. Under no circumstances you have to risk your life. It's not worth it. And then you have to be very safe around it, and you have to be smart. Basically you have to be thorough. You have to know whether your body is acting as a ground or not. You have to be calm, and I'm reasonably sure all of you have like hundreds of video plastered on your televisions, like, you know, teaching. And when you're at school, there's a very good chance they might have showed you direct videos of, like, you know, how to make sure that you are not grounded, to not touch a live wires and all that. So I'm pretty sure you know how these things work. So be mindful. And if you want to learn these things, if you are like, hey, I want to install a solar farm on my rooftop, I need to understand, hey, is it creating the ampere? Or there's a very good scenario where if you know these things, you will know, hey, my solar panel is supposed to give the power, and I'm checking it, it's giving the power, but my inverters are not giving the power. That means there is an inefficiency in your charge controller. If you do not know voltage and amperes, you cannot check it. All you have to do is rely on someone else. Now that's okay and all that, but again, if you were trained this, like you were taught this, and look, sorry, power cut happened. So in low voltage scenario, you can easily check it without risking anything, and you have to know this thing, like you rely on these things. So be calm, be mindful, and if you have any doubt, don't screw around with things that you could literally end your life. So be mindful, and I'm gonna make part 2 going more into detail with auto select and all that jazz. So this was my first part of a multimeter series. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.